Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. So we're working on memory and storage, a red topic. And as I explained, this subtopic here of numbers is such a large topic that we're going to only look at one bullet point per video. So this is where we're focused today. So pause the video and take stock of what you already know. And once you've done that, if you fill in the slip in your green book, and then we're ready to learn. So why are we adding two denary numbers together? Well, the reason we're doing that is because we're learning how to add binary numbers together in this video. So we're going to remind ourselves of how we do that in denary, because both follow the same principle. So if you pause the video and have a go at adding these two numbers together without using your calculator. And now I'm about to show you the answer. So here we start on this side always, and 9 plus 0 is 9. 5 plus 7 is 12, and that means it's 2 carry 1. And 1 plus 4 plus 6 is 11, so our answer is 1129. There's two things I would like to point out to you here. We added a 3-digit number and another 3-digit number together, and our answer was 4 digits long, and that's okay in denary. We also had a carry here, and it's really important when you add two binary numbers together, when you have a carry, that you show it, so the examiner knows you understand the method and you follow it fully. We're now going to count to 3 in binary, and the reason we're doing that is because when you learned how to add in denary, you already knew how to count. So 0, 1, 2, 3. Okay, let's look at that again. 0 is just 0. 1 is 1, and we've got a leading here, 0 here, 0, 1, because we're using 2 bits. 2 is 1, 0. So 1 times 2 plus 0 times 1 is 1, 0. So in binary, when we want to represent 2, we have to put a 1 under the 2 column. And the reason that is because when you think about denary, if you were counting in denary, you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You've run out of digits, so you've got to go to the next column, 10. So that 1 will represent 10, and you will have 1, 0. So that 1 there is that 1, 0 is our 2. So we've got that 1 in the 2's column. 3 then is 2 plus 1 is 3. Okay, this is actually as easy as it looks. So have a go at adding these two numbers together. So 1 plus 0 is 1, and 0 plus 0 is 0. So what we've done is we've added 1 and 0 together, and we've got 1 as our answer. And now if we add 1 and 1 together in binary, so 1 plus 1 is 2, but we know that is 1, 0. So that would be 0 carry 1. 0 carry 1. And then 0 plus 0 plus 1 is 1. So we have learned that 1 plus 1 is 1, 0. And the last 2-digit binary number we're going to add together. So 1 plus 1 plus 1 is 3. And we show a 3 as a 1, 1. So we have got 1 carry 1, and then we've got 1 plus 0 plus 0 plus 0, and that is 1. So we have learned that 1 plus 1 plus 1 is 1, 1, which is 3. Now, I'd like you to have a go at adding these two nibbles together but I've left this here to help you out. So pause the video, have a go. And now I'm about to reveal the answer. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1, look at it up here, 1 plus 1, that's 1, 0, so we have to put the 0 down and carry the 1. So 1 plus 1 is 0, carry 1, and 1 plus 0 is 1. So the answer is 1011, and 1011 is 8 plus 2 plus 1, which is 11, and this number here is 4 plus 2, which is 6, and this number here is 4 plus 1, which is 5, so 5 plus 6 is 11, so I'm happy. Now, you could have, if you wanted to, converted this number to 5 and this to 6 and said 5 plus 6 is 11, and then worked out you'd have to put a 1 here, here, and here for your 11. That's actually not allowed in the exam because the examiners are testing that you know how to add two binary numbers together. There are other parts of the exam where they can test whether you can convert binary to denary and vice versa, but they actually need to see, and the only way they will know will be actually that you show your carries. So where you get a correct answer like this, you will only get full marks if you've also shown your carry. So you need to get in that habit. There's absolutely no harm somewhere roughly checking your answers, but make sure you show the carry. Okay, another one for you to have a go at. So if you pause the video, have a go at this. And now I'm going to reveal the answer. So starting again, as always, from this side, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. And 1 plus 1 is 0, carry 1. Now, obviously, we're at the end here, so we've just put the 1 here, but I've drawn this red box around it. And the reason I have done that is because we have added a nibble and a nibble together. So if you remember, a nibble is 4 bits, and we actually only have a nibble to store our answer in. So the answer that we have here is 0011. So the answer we have is 3. We have added 12 and 7 together, and we have come up with the answer of 3. And that's clearly wrong. 12 and 7 is 19. So the answer is wrong, and it's an error, and that is known in computer science as an overflow error. So an overflow error is when your answer is too big to fit in the number of bits you have available, and this is the overflow bit. If this had been counted, if we had the space for this, well then that would have come under 16, and we would have had 16 plus 2 is 18, plus 1 is 19, and it would have been correct. But actually, no, it's wrong. This is a question that the exam board love to ask. They may get you to add two numbers together and then ask you to comment on your results. And what they're looking for there is if there had been an overflow error, did you spot it and did you know what it is? Okay, so again, we're going to look at one 8-bit question. So we're adding 2 bytes together. So if you pause the video and have a go at doing this. Okay, I'm going to show the answer. So we have 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 plus 1, well, let's just check over here. 1 plus 1 plus 1 is 1, 1. So it'll be 1, carry 1. And then 1 plus 1 is 0 carry 1. And then 1 plus 0 is 1. And 1 plus 0 is 1. So well done if you got that right, because I have included 4 carries, which is actually quite complicated. Now, you actually need to approach these questions and do them slowly. There is time in the exam, so take your time and take care, because really what you're doing is quite easy. You're just adding ones and zeros, and sometimes you will have 3 ones to add together, which you have to remember is 1, 1. So one tip is just to write these down in the exam on the corner of your the paper you're writing on, just as like a little plan for yourself, so you can refer back to it. But the other tip is to go very slow, because there's too many times now where I've seen a student just miss out on marks here because they rushed this. And if you rush it, it's actually easy to make a silly mistake, okay? So, what have we learned in this video? We've learned that adding binary numbers follows the same principle as adding denary numbers. It's very important to show carries. And we've also learned that when the result of addition is too big to fit in the bits available, an overflow error occurs. Okay, so I hope you've enjoyed learning about binary addition and that you've mastered it. But please take stock now of where you are with this topic and then fill in the slip in your green book. I hope that you have made progress, but that is it now for this lesson.